Hello everyone, it's test review time. So we're going to go through basically the proofs and then our sum and difference formulas, and that's pretty much it using those properties. So first one, it says simplify. Let's see. Anytime I see something squared in a 1, I think that's got to be a thing, right? Like 1 minus cosine squared, that's sine squared. So let's make that sine squared x times cosecant is 1 over sine of x. So I'm thinking, hey, look, I can cancel out one of the signs, and you just get sine of x. So, sweet. Fast way of doing it. The other thing you might do is distribute the cosecant, and you'd see then you have a cosecant minus 1 over sine. You have to get a common denominator. It's more work that way. Really, if you see that you have something squared in a 1, you should be thinking that's probably a thing. And that's going to keep you doing these a lot quicker, basically. So, 1 minus cosine squared. Hey, wait a minute. That's sine squared. Right? Yeah? Sine squared over secant squared x minus 1. It's tangent squared. Okay? So sine squared over tangent squared. So just using my properties, like I said before, if you know that you've got a 1 and something squared, you can use these properties. And then I can do copy, change, flip really quickly. Sine squared x, that's in the numerator, sine squared over 1. And then in the denominator, I have tangent squared, which is sine squared x over cosine squared x. And when you copy, change, flip, you get sine squared x over 1 times, you flip this, cosine squared x over sine squared x, and those cancel, and you end up with cosine squared x. Cool. Now, what if you didn't think to use that property, especially the bottom one? You might have done sine squared in the top. So let's say you did sine squared in the top. You're like, hey, that is a thing. This is sine squared x over. And then you don't catch it in the bottom. It's not that big a deal. You can get away without seeing, especially the secants and the cotangent and all that stuff. Really, the sine and cosine ones you need to know, but the other ones you can get away with because it's not that hard to do this. Same thing. This is secant squared minus 1. And now what I need to do is get a common denominator. So the common denominator here would be cosine squared x over cosine squared x. And then you end up with your sine squared x in the top. And in the bottom down here, I have 1 minus cosine squared x over cosine squared x. And then you're like, oh, wait a minute. That's sine squared x. And you're in the same exact spot now. Sine squared x over sine squared x over cosine squared x. So it ends up being the same thing. If you don't see the denominator, you can always convert everything to sine and cosine and work through it that way. But you'll notice from here, once I do that substitution, this is now sine squared, and it's the exact same steps on out. Okay? So if you don't see the secants or the cosecants or all that stuff, you can usually get it to a sine or cosine by converting what you do have into sine and cosine. Let's see, cosine squared plus cosine squared x times tangent. If I see something like this, like I'll do this a couple ways. First, I'm thinking if I factor out a cosine squared x, I'm going to be in business. Okay, because they have a GCF of cosine, so the cosine will go out, and then you're like, hey, 1 plus tangent squared x. That's a thing. That's secant squared x. Secant squared x. And then you're like, wait a minute. That's cosine squared x times 1 over cosine squared x. This is 1. Okay. That's one way to do it. Let me try maybe do it another way and see if that makes it easier for you to see. We'll do cosine squared x over 1 plus cosine squared x over 1 times sine squared x over cosine squared x. All right, so how would I go about maybe doing it this way? First, I would need to get a common denominator. So this guy's denominator is cosine squared. This guy's denominator is cosine squared. And you're like, man, to the 4th power, cosine to the 4th x plus cosine squared x times sine squared x. And you do all this, and you're like, man, this is awfully high degree to the 4th power. And that's sort of like my giveaway, like, yo, if you're higher than degree 2, you should be factoring. So we're higher than degree 2. We have a quartic. So what I'll do now is I'll look for the GCF of this, which would be, cosine squared. So cosine squared x goes on the outside. You have cosine squared x. So cosine squared times cosine squared is cosine to the 4th. And if you factor out the cosine squared here, you still have a sine squared x. And then this is all over your denominator, which is cosine squared x. These cancel, and you get, hey, that's a thing, that's 1. So again, it equals 1. So how do you want to go about doing it? If you know the properties, you can do it pretty much right away. If you don't, doesn't mean you can't solve it. It just means it's going to take a little bit more work. Now this one I think was more of an obvious thing because you saw it was higher than degree 2, but really, if I see that I can factor out something, I'm probably going to try it and see what happens. I factored out cosine squared, got an identity, crushed it. All right, let's see. Probably don't have a lot of options here, but make this all in terms of sine and cosine, I'm thinking. So let's do the sine of theta over the cosine of theta plus cotangent is the cosine over the sine of theta. And in my denominator, I have 1 over the sine of theta. So let's get a common denominator in the top. That means you have to multiply them together. So this guy needs a sine of theta, and this guy needs a cosine of theta. And I'm like, ooh, spidey sense. That's going to be sine squared plus cosine squared at the top. So when I simplify the top, I have a denominator of sine times cosine. So sine of theta times cosine of theta. And then if you look up here, you have sine squared theta plus cosine squared theta. See, sine times sine is sine squared, cosine times cosine is cosine squared, and you'd be thinking, hey, that's a thing, that's 1. Cool. In the denominator, I haven't done anything. I still have 1 over sine x. Cool. So I will now copy, change, flip. So now it's sine of theta over 1. And remember, this is 1. So I'll just write it like that. And now I got that, and you're like, hey, wait a minute, sines cancel. 1 over cosine is the secant of theta. Sweet. Probably the most likely way you guys are going to go about doing that. Make everything in terms of sine and cosine, get a common denominator, copy, change, flip. We've done a lot of those. You should be pretty comfortable with the steps in that process. Okay, there's a pretty straightforward Pythagorean identity and getting a common denominator. Any more proofs? No. Okay, so that's it for your verifies. Let's do some maybe of these identities. So it says evaluate exactly cosine of 165. Let's find 2 angles that we do know on the unit circle that add to 165. How about 120 and 45? Now, the trick is, if you know you are adding, you have to use a property. You can't just distribute cosine. It's this property. So I will say it's the cosine of the first angle, 120, times the cosine of the second angle, minus the sine of the first angle times the sine of the second angle. And now I evaluate on my unit circle. Let's draw that. 120 is in the second quadrant, a 60-degree reference angle. So the cosine of that would be negative 1/2 because it's the short leg. 45 is radical 2 over 2. Sine of 120, that's the long leg, radical 3 over 2. And the sine of 45 is radical 2 over 2. So this ends up being, remember the denominator is always 4 for these, because 2 times 2 is 4. You got negative 1 times radical 2, that's negative radical 2, and negative radical 3 times radical 2, which is radical 6. So negative radical 2 minus radical 6, all over 4. And you can check these. So you got your calculator. You're going to say, all right, let's check it. We're going to do the cosine of 165. Oops, 165. And then we'll check it. Negative radical, oops, whoa. Negative radical 2 minus radical 6. And I'm going to have to divide this whole thing by 4. Do I get it? Hey, same thing, 0.965, 0.965. Awesome. So I know what I did right. Cool. Tangent of negative 7 pi over 12. All right, this is going to be a little bit of work because remember, we don't want to use any 30-degree reference angles. Oh, let's see. Let's do what we know. We know pi over 6. Oh, we don't want to use pi over 6. That's a 30 degrees, so we're not going to use pi over 6. We know pi over 3. That would be 4 pi over 12. And pi over 4 would be 3 pi over 12. If I look at those two, like those add to 7. But what if we make them both negative? So we'll take the tangent of negative pi over 3, and I'm going to add negative pi over 4. Now, you can do this several ways. You can make them both negative so that they add to a negative, or you could also, if you wanted to use the subtraction formula, you could subtract them. But you have to be really careful. If you do the subtraction formula, then your first variable will be negative, but your second will be a positive pi over 4. So just to be consistent, I'm going to make the angles both negative. But that means that my S and my T are both negative angles. I'm going to use the addition formula. So I'm going to use actually this formula, but my angles are negative, which is kind of tricky. And like I said, you could use the subtraction formula and then just make the first angle negative, but I think it makes the most sense for me to make both angles negative. So when I use my formula, I'm going to say the tangent of the first angle, which is negative pi over 3, and plus the tangent of the second angle, which is negative pi over 4, over 1 minus the tangent of negative pi over 3 times the tangent of negative pi over 4. That's times. Okay. So you just got to remember that we are dealing with negative angles. That means we're actually in the fourth quadrant. That's just to make sure you understand this. The argument is negative. We're not subtracting. So tangent of negative pi over 3, it's a 60-degree reference angle. So you know it's radical 3, and in the fourth quadrant, it's negative. So the tangent of negative pi over 3 is negative radical 3, plus the tangent of negative pi over 4, that's down here. That's when x and y are the same. So it will be 1, except that x is positive and y is negative, so that means it's negative 1. So we'll write this as, I'm going to put minus 1 over 1 minus, now again, this is negative radical 3 times negative 1. So negative radical 3 times negative 1 is positive radical 3, and we are subtracting positive radical 3. Okay, this comes out to be radical 3, and 1 minus will be 1 minus radical 3. So again, you got to be really careful with the signs. That's the tricky thing with these. Once you got it set up, you're going to use the conjugate like we always have been doing. So from here on out, it's pretty much the same game. We'll do 1 plus radical 3 in the top and the bottom. Now when I FOIL, I got radical 3 times 1, which is radical 3. Negative times a positive is negative. And radical 3 times radical 3 is 3. Negative 1 times 1, negative 1. Negative 1 times radical 3, negative radical 3. Just foiling. You should know this is negative 2, but 1 times 1 is 1. Plus radical 3, minus radical 3, and then positive times the negative is negative. Radical 3 times radical 3 is 3. Those cancel out, and you get negative 2. You should just be able to do that in your head. Negative 2 in the bottom. Radical 3 and radical 3, that's 2 of them. They're negative, so negative 2 radical 3s, and negative 3 minus 1 makes negative 4. So finally, when I distribute the negative 2, which is, I'm really distributing a negative 1/2, negative divided by negative is positive radical 3, and negative divided by negative is positive 2. So radical 3 plus 2. Let's see how we did. So I'll use my calculator, and I'll just go back to that. We are trying to find the tangent of, I got to make sure I'm in radians, negative 7 pi over 12. So mode, radians, boom, tangent, negative 7 pi over 12. That's not 12. There you go. Did we do it right? We think it's 2 plus radical 3. 2 plus radical 3. I'm feeling good about it. Let's go. Okay. So the trick to that is I made both of the angles negative, and then I added them together. So when I was still using the addition formula, which means in your tangent expansion, you're going to have a plus in the top and a minus in the bottom. Because again, I'm using the plus in the top, minus in the bottom. I just made the angles negative. Tangent's always weird. That one's tricky. All right, let's do some verify problems. I'm telling you the question and the answer, so these are just ones where you have to be really careful. Show me all your steps. Let's see. How would I want to go about doing this guy? I think I'm going to distribute. So I'm going to just multiply. We'll do sine of theta times cosine of theta. So this is going to get times tangent, which is sine of theta over cosine of theta. Plus, I'll do the same thing. Sine of theta times cosine of theta, but now it's times cotangent, which I'll write as cosine over sine. Now, can I simplify this at all? I feel like I can just do that, and then I can do that. And I'm like, oh, look at this. Sine squared theta plus cosine squared theta. That's a thing. That's 1. That's what I was trying to prove. Sweet. So I distributed, made everything in terms of sine and cosine. Done. Got an identity. Now when you see one like this, you need to know that that's a thing. That's a property. Here's my properties again. You have a sine difference formula. So I'm going to steal this. I'm subtracting sine. Give me this guy. Nope. Come here. Copy, cut, we'll cut, and paste. If I'm subtracting angles, you need to know that that's a property, and I will give you this property on the test. I won't give you the IDs, the Pythagorean IDs, but I'll give you this one. So we're going to do the sine of the first angle times the cosine of the second angle. So the sine of x times the cosine of pi over 2. And it's minus. We put minus the cosine of x times the sine of pi over 2. And just plug it in. S is x and t is pi over 2. So x pi over 2, x pi over 2. Now you got to remember that pi over 2 is one of those quadrant angles. That's up here. And I like to label that. That's 0, comma 1. The cosine of pi over 2 is the x. So that's 0. 0 times the sine of x goes away. And the sine of pi over 2 is the y. That's 1. So 1 times the cosine of x. And that's negative 1 times the cosine of x, which is, hey, negative cosine x. We did it. So usually these are really easy because you are just following a property. You don't have any choice on what to do. If you see a sum or difference, use the sum or difference formula. And it'll usually clean up in like one step. You just got to know the cosine of pi over 2 is 0 and the sine of pi over 2 is 1. What else you got? Some identities, but these are going backwards. So I think these are really easy if you know what to look for. You're looking for a property, but it's been expanded. So if you see sine times cosine plus cosine times sine, look for that. Where is that? Sine times cosine plus, nope, not that one. Sine times cosine plus cosine. It's this identity. So they used this sum identity, but they had already expanded it. They said that 18 was your S and 27 was your T, which if you take those and plug them in over here, then you're saying, well, that's the sine of 18 plus 27, which is the sine of 45, which is radical 2 over 2. So they went backwards. Now you can check this, and it's going to look kind of crazy because I don't know what the sine of 18 is or the cosine of 27 is plus the cosine of 18 times the sine of 27. And you get that. Is that radical 2 over 2? Uh-oh. No, it's not. What did I do wrong? Oh, I'm in radians. I need to be in degrees. Okay. Wait, I'm pretty sure I'm right. Let's go back up and try this again. In degrees. Hey, there we go. Okay. You got to make sure you're in the right angle measure. If you're doing degrees, you better use degrees. So radical 2 over 2, 0.707. Sweet, we did it. Okay. Same idea here. You see cosine, cosine plus sine, sine. So cosine, cosine plus sine, sine, that's this one. This is the cosine subtraction formula. So this is the cosine 3 pi over 7 minus 2 pi over 21. You're like, oh my gosh, I need a common denominator. Let's triple this guy. If you multiply that top and bottom by 3, you get 9 pi over 21. So I am getting a common denominator. I'm multiplying the top and bottom by 3. 9 minus 2 is 7 pi over 21. 7 over 21, that's 1/3. What's the cosine of pi over 3? Pi over 3 is like that. Cosine's the short leg. Cosine is 1/2. Sweet. So I'll check that one too, just for good measure. Cosine, I got to go back to radians though. Cosine of 3 pi over 7 times the cosine of 2 pi over 21 plus the sine of 3 pi over 7. If I'm going to type all this in, I better get 0.5 times the sine of 2 pi over 21. Come on, 1/2. Let's go. Be a math teacher when I grow up. Awesome. Okay, we did it. So that's really it. You got some simplify, some verify, and then your sum and difference formulas. You might need to do the verify problems, but if you can do these study guide questions and you've done your portfolio and you've done your checkpoint and you know the unit circle, there's nothing I can throw at you. So good luck. Make sure you hit that like and subscribe button, and I'll see you later.